What's up, guys? Happy Tuesday. Today we're going to continue on with solving quadratic equations, but we're going to learn a new method today that we're going to have to use in certain cases. And I'm going to start off by showing you the difference between what we learned yesterday and what we're learning today. So, yesterday we were solving by taking square roots. So, this first example is an example of one of those problems, right? I know it's quadratic because I got the x squared, right? So to solve this, eventually I'm gonna have to take a square root, but hopefully y'all remember that first, I've got to divide both sides by 3, right? Because I'm trying to get that x completely by itself. So I'm gonna start by getting rid of that 3 multiplied out front. 3 divided by 3 is 1, so I have 1x squared. 27 divided by 3 is 9. And now, if you remember from yesterday, now the only thing I got to do to get x by itself, well, if x is being squared, the opposite of squaring is taking the square root. So if I do that to both sides, the square root of x squared is x, the square root of 9. And if you remember yesterday, this is a little different. This is new for us. Positive and negative 3, right? And I encourage you, if you go back and plug these in, plug in positive 3, you'll get a true statement. Plug in negative 3, you'll get a true statement. So oftentimes with quadratics, we'll have 2 solutions, right? So that was solving by square roots like we did yesterday. I want you to look at example 2 for a minute. What's the biggest difference between this equation and this equation? Hopefully you're noticing that this one also has an x term, while this one doesn't. This one just has an x squared. This one has an x squared and an x, right? All the problems we worked out yesterday with the square rooting examples, they only had an x squared. They never had an x with it, right? So because of that, we are going to need a new method. Because of this 7x right here, we're going to need a different method to factor or to solve quadratic equations like this. And that new method is solving by factoring. So all that time we spent factoring a couple weeks ago, this is where it's really going to start coming in handy. We're going to need to know how to factor in order to solve equations like this. So I'm going to break this down into 3 steps, and then we'll do a couple of problems to practice it out. So if you're looking at this equation, x squared plus 6x minus 27 equals 0. I know this is an example of this new type of problem that we haven't tried yet, because not only does it have an x squared, but it's also got an x term, right? And if you notice, this is just standard form, right? Ax squared plus bx plus c. So the first thing you want to do when you're solving a quadratic equation like this that has both an x squared and an x term is you want to make sure the equation is equal to 0. And that'll make sense in a minute as to why. But the first thing we got to do, make sure it's set equal to 0. And in this case, it is. So the next step, after we've made sure our equation is equal to 0, is we're going to factor. We're going to factor this expression on the left-hand side. And if you remember, now that I know I've got a standard form quadratic where a is 1, I know it's going to factor into x and something times x and something. And I just got to figure out what these 2 numbers are. So what are the 2 numbers that multiply to negative 27 and add to 6? 2 numbers that multiply to negative 27, add to 6. And those numbers are positive 9 and negative 3. So x plus 9, x minus 3 is our factors on the left side. And setting equal to 0 just because we're bringing that down from the step before, right? So this equation and this equation are both equivalent with that left-hand side factored. And our third and final step is we're going to set each factor equal to 0. And then we're going to solve for x. So the idea of this is that if you've got something times something else, right? In this case, this factor times this factor equaling 0. then one of these two things, at least, has to equal 0, right? Something times something else equals 0. That means either x plus 9 equals 0 or x minus 3 equals 0. So that third step, take each factor and set it equal to 0, and then solve for x. And what you get here, you should have two really simple equations. X plus 9 equals 0. I've got to subtract 9 from both sides. And I've got x equals negative 9. And here, x plus 3 equals 0. X minus 3 equals 0. I've got to add 3 to both sides. And I've got x got x equals positive 3. So I've got two solutions, just like we've been seeing, right? Now I want to kind of shed light a little bit on what's going on here. So we just solved this equation by factoring, right? We noticed that it not only had an x squared, but it had an x term. So that pointed us to the fact that we needed a new method, and that method is called factoring. Step 1, make sure the equation is set equal to 0. Step 2, factor that quadratic expression on the left side. Step 3, set each of those factors equal to 0 and solve. And we got our two answers, x equals negative 9, x equals 3. So let me show you the same equation on the next page, graphed, right? So x squared plus 6x minus 27, the same quadratic equation, right? Graphed. So first thing I want you to realize is that when we factor that quadratic portion into x plus 9, x minus 3, if you remember from the other day, that's intercept form, isn't it? Right? And remember how we had to change these signs, right? If it was plus 9, that the x-intercept would be negative 9, 0. And look, it is. Minus 3, the x-intercept would be positive 3, 0. Well, the reason these signs change to the opposite sign is, if we look at the previous page, because of this step we did here, right? By having to do the opposite operation in order to get x by itself, right? Plus 9, we had to subtract 9 from both sides. Minus 3, we had to add 3 to both sides. That's why these symbols change to the opposite sign when we're talking about the x-intercepts, right? And notice how it's got to be set equal to 0. Well, that means the y value is 0. And whenever y is 0, I know I'm on the x-axis. So when we're solving these quadratic equations, we're actually finding the x-intercepts, which we also call solutions. So hopefully that helps you kind of visualize what's going on here. Let's try out another example. X squared plus 3x equals 18. So again, this is our new type of quadratic equation, different from yesterday, because now not only do I have an x squared term, but I also have an x term. This means I need to solve by factoring. So if you're thinking about the three steps, that step number 1, I need to have both sides equal to 0. I'm sorry, I need to have one side equal to 0. So you see how I've got this 18 over here? Well, I want it to equal 0. How do I make 18 equal 0? I subtract 18. But whatever I do to one side, you guys know I got to do to both. So 18 minus 18, and I'm going to have equals 0 over here, right? Now, x squared and 3x. Do I have a like term with this minus 18? So it can't combine with anything. That means it's just going to be x squared plus 3x minus 18. So our step number 1 was to get the equation equal to 0, and we did that by subtracting 18 from both sides. Our step number 2 is going to be to factor. And I know I've got a quadratic in standard form where a equals 1. That means it's going to factor into x in something times x in something. I know it's going to equal 0, carrying that down from before. So to figure out these two numbers, I got to know what two numbers multiply to negative 18 and add to 3. Those numbers are positive 6 and negative 3. So we've set it equal to 0, step 1. We've factored it. That was step 2. Step 3, we've got to set each factor equal to 0 and solve. So x plus 6 equals 0. I've got to subtract 6 from both sides. And I've got x equals negative 6 for one of my solutions. For this right equation, I've got to add 3 to both sides. And I've got x equals 3. So here are my two solutions for this quadratic equation. If I plug in negative 6, I should get a true statement. If I plug in 3, I should get a true statement. And the last thing I want to show y'all real quick is let's just kind of visualize what's going on here. So if we sketch a rough sketch of the graph, I know it's going to look something like this. Opening up, the y-intercept is going to be negative 18, somewhere down here. But the really important part that I'm trying to focus on is right here. I know this x-intercept is going to be negative 6, 0. I know this x-intercept is going to be 3, 0, because that's what I solved for here. So this is a big step forward for us in solving quadratics. So definitely encourage you, go back, rewatch some examples, try out some problems on your own maybe, and go to Canvas, do the practice assignment, and please message me on Canvas, email me, message me on Remind if you got any questions. And yeah, I'll try to get back to you as quickly as possible. Y'all have a great rest of your day.